Problem 4.42 of Sonntag. We have a piston cylinder arrangement which contains 1 kg of water at 20 degrees Celsius with a linear spring mounted on the piston such that when the water is heated, the pressure reaches 3 megapascal with a volume. So, pardon my bad drawing, but we have a piston which is spring loaded. So this contains 1 kg of water at an initial state T1 equal to 20 and P1 equal to 300 kilopascal. The final state is 3 megapascal with a specific with a total volume is equal to 1 meter cubed. We must find out the final temperature, plot the process in a PV diagram, and find the work done during the process. So the basic idea is we know the properties of the initial state and we know the mass. Because of this we can find out the specific volume. Having known the specific volume and the mass of the fluid, we can find the total volume initial. We know the final pressure and the final volume based on the fact that for a spring-loaded piston, the process on a PV diagram is resembled by a straight line. The work done is equal to half P1 plus P2 multiplied by P2 minus V1. Okay, let's see how this checks out. So we have mass equal to 1 kg. T1 is equal to 20 degrees Celsius. P1 is equal to 300 kilopascal. P2 is given as 3 megapascal. And the total wall at state 2 is equal to 0.1 meter cubed. Okay, so for the initial state, the specific volume state 1 is equal to volume T equal to T1, P equal to P1. I forgot to write the name of the substance. That's okay. So the initial volume is equal to specific volume multiplied by the mass, which in case is 1, makes no difference. So the work done is equal to half times P1 plus P2 multiplied by wall 2 minus wall 1. Let's see. The work done is equal to 163 kilojoule. We need to plot it on a TV diagram. So we go to plots, property plots, steam, PV. Okay, there we are. Then we go to plots, overlay plot. On the x-axis we have specific volume, on the y-axis we have the pressure. Missing data in row 2 for specific volume. Okay, let's see what the missing data is. We don't have the specific volume at state 2, that is why the computer threw an error. So let's do that. Let's find the specific volume at 2. SP wall at 2 is simply equal to the volume at 2 divided by the mass of the system. There we are, pardon me. There we go. So we now go to plots, overlay plot, specific volume versus pressure. There you go. The process happens to be a straight line connecting the 2 points. Evidently the first point is subcooled liquid Okay, and the second point is superheated vapor. The pressure has gone linearly as a function of temperature, as a function of the volume, because we had a linear spring attached to the problem. I hope this problem is clear.